In question number 7, two blocks of mass small m and capital M are connected by means of a light metal wire passing over a frictionless fixed pulley. The area of cross section of wire is 15 into 10 to the power minus 9 meter square and its breaking stress is 2 into 10 to the power 9 Newton per meter square. If M is equal to 8 kg, then the maximum value of M so that metallic wire does not break is 24 by K kg. Find the value of K. So if I analyze the situation, suppose this is the pulley and suppose this is a small mass M and this is capital mass, another block of mass capital M. So if this is fixed, then we can calculate the tension in the string. So if these two masses are M1 and M2, then the tension comes out to be 2M1 M2 G divided by M1 plus M2. So if I calculate the tension directly, so it can be written as 2 into small m into capital M G divided by small m plus capital M. Since the tension is this in the wire, so if I calculate the stress, that is T by A. So if I calculate sigma, so this is equal to T by A, so I can divide this by A. And this sigma is given in the question in the form of breaking stress. So when M is maximum, then the value of sigma is equal to breaking stress. So if I divide this equation by capital M, then in the denominator it comes small m by capital M plus 1. So when capital M is maximum, the denominator will be minimum, and in that case sigma will be maximum. So we can say that sigma is maximum when capital M is maximum. So we can directly find out the value of capital M from this equation. So sigma is given in the question, that is 2 into 10 raised to the power 9 into area, that is 15 into 10 raised to the power minus 9 is equal to 2 times small m, that is 8 into capital M into G, value of G is 10 divided by 8 plus capital M. So if I solve this equation, the value of capital M comes out to be 24 by 13 kg. So on comparison, we can say that the value of K is equal to 30. So the correct answer for question number 7 is 30. Let's move to question number 8. In question number 8, a stone is projected from horizontal ground with minimum initial velocity V0 meter per second such that the stone is able to cross a sloped roof AB as shown below. Then we have to calculate the value of V0. So the logic behind the problem is that when we projected the stone with a minimum initial velocity, then it must passes through point A and B while making its projectile. So we can say that suppose if I project with a speed V0 at this moment from the ground, then it will move in this way and it comes down by touching at point B. The projectile is something like this. So I can say that let if at point A the velocity is V, then we can calculate the value at point A. Then we can calculate the velocity at point A. So V square is equal to V0 square minus 2 times G into displacement in y direction, that is 10. So this is the velocity at point A, and if U is minimum, then we can say that AB is the maximum range on the inclined plane if I consider this as my inclined wedge. So if I consider this as my angle alpha, then AB is the maximum range on that inclined plane. So I can say that on solving, the value of AB comes out to be V square, where V is the velocity at point A, divided by G into 1 minus sine alpha, where alpha is the angle made by this incline AB with the horizontal as shown. So now we know the value of AB, that is 25. So if I see this length, then this will be 25 sine alpha. So I can say that 25 sine alpha is equal to 10 minus 5. So that is equal to 5. So from here we can calculate the value of sine alpha. So sin alpha is equal to 1 by 5. So if I substitute the value of AB, so that is 25, into G, that is 10, into 1 minus sin alpha, so that is 1 minus 1 by 5 is equal to V square. That is the square of the velocity at point A. And this we have already calculated, V0 square minus 20 into G, that is 10. So if I calculate the value of V0, it comes out to be 20. So the correct answer for question number 8 is 20. Let's move to question number 9. So in question number 9, a force F is equal to 60 Newton is applied at one end of a string, the other end of which is tied to a block of mass M is equal to 10 kg. The block is free to move on a frictionless horizontal surface. At initial instant, theta is equal to 37 degree. At an final instant, theta is equal to 53 degree. For the time between two instants, the work done by force F on the block is 2k joule. So we have to calculate the value of k. So we can say that, suppose if initial position is this and the final position is this, and in the final position this makes an angle of 53 degree with the horizontal. So in this case, the work done by the force F can be said F into delta L, where delta L is the displacement of the point of application of force. So first of all, I am calculating the value of delta L. So delta L can be written as 2 divided by sin 37 degree, that is the initial value of this L1, minus L2, this is the final value L2, so that is equal to 2 divided by sin 53 degree. So on solving this, this comes out to be 10 by 12 meter. So if I calculate the work will be, the value of F is 60 into delta L, that is 10 by 12. So it comes out to be 50 joule. So if I compare, the value of 2k is equal to 50. So the value of k is equal to 25. So the correct answer for question number 9 is 25. Let's move to question number 10. In question number 10, two smooth incline lie within the same vertical plane and makes an angle theta to the horizontal as shown. At time t equal to 0, two small balls are released from point A and B simultaneously and they start sliding down. It takes 24 seconds for the first ball that started from point A to reach the ground, and for the second one the time of descent is 16 seconds. So suppose ball 1 is this, so the time taken by this ball to reach from here to here is 24 seconds, and the second ball is this, and time taken by this ball to reach from point B to the ground is 16 seconds. So at this instant it is given that the distance between the ball is minimum, so we have to calculate the value of n. So first of all, analyze the situation. At t equal to 0, the first ball is at this position and the second ball is at this position. So we can say that the effective separation in x direction between them is this. So if I say this is as delta x, then delta x can be written as, if I consider this as my L1 and this is my L2, then I can say that this delta x is equal to L1 minus L2 cos theta. So we can say that the value of L1 is half into G sin theta. So first time 24 seconds I am considering as T1, so that is T1 square, and L2 is equal to half into G sin theta into T2 square, and T2 is my 16. So from here I can say that delta x is equal to half into G sin theta into cos theta into T1 square minus T2 square. So this is the separation in x direction between them at t equal to 0. So suppose they starts moving at any time t, the first ball reaches to this position and the second ball reaches somewhere to this position. For separation between them to be minimum, I can say that they must be in vertical direction, so that the distance covered by this and the distance covered by this, the summation of these two distances must be equal to delta x. At that moment, t is equal to under root n into 10. So if I write delta x between them at any time t, so that can be written as delta x at any time t between them, that is equal to delta x minus half into ax relative. So relative acceleration in x direction between them into t square. So when t is equal to under root n into 10, the value of delta x dash must be equal to 0. So because delta x dash represents the relative separation between them in x direction. So now I have to check what is the value of ax relative. So the acceleration of the first ball in this direction is g sine theta into cos theta, because this angle is theta. Similarly, the acceleration of second ball in this direction is g sine theta into cos theta, because this angle is theta. So the relative acceleration ax relative is equal to 2g sine theta into cos theta. So I can say that at t is equal to under root n into 10 seconds, the value of delta x dash, that is the relative separation between 1 and 2, must be equal to 0. So I can say that in that situation, delta x is equal to half ax relative into t square. So half ax relative, that is 2g sine theta into cos theta into t square, is equal to delta x, that is equal to half into g sine theta cos theta into t1 square minus t2 square. So on solving this, the value of t comes out to be under root t1 square minus t2 square by 2. So if I substitute the value of t1 is equal to 24 and t2 is equal to 16, then I can find this is equal to under root 160. So on comparison, we can find the value of n, so that comes out to be 16. So the correct answer for question number 10 is 16. Let's move to question number 11. In the question number 11, in the figure shown below, all surfaces are smooth. The string and pulley are light. If the system is released from rest, then the tension in the string is k Newton. Find the value of k, and it is given in the question the value of m is 18 kg. So if I draw the free body diagram, then this is my 4m wedge, and this is the pulley which is attached to this wedge. The tension T is acting in this direction and the tension T is acting in this direction. Since this wedge is kept on the horizontal surface, so if I assume let the acceleration of this wedge is a in this direction, then I can say that T is equal to mass into acceleration, that is 4m into a. So the value of T is equal to 4ma. If I analyze the situation of the block, so this block is of mass m, it is connected by the string, this is the pulley, and this is another block of mass m. So at t equal to 0, I can say that if I study the motion of this system in the frame of reference of the 4m wedge, then I can apply a pseudo force. So if m is the mass of this, then I can apply a force m into a on this, and suppose in this frame this is moving with an acceleration a1. I can say that if I apply the equation for this block A, then for A I can write tension T will act in this direction. So T plus ma is equal to m into a1. So I am writing this equation in the frame of 4m wedge. So substituting the value of T, that is 4ma, so it is equal to 5ma is equal to m into a1. So this is my another equation. If I write this equation for this block in vertical direction at this moment, so at this moment if I write mg will act in this direction and t will act in this direction and is moving downward with acceleration a1. So if I write the equation, so that comes out to be mg minus T is equal to m into A1. So if I substitute the value of m, A1 and T in this equation, then I can get mg minus 4ma is equal to 5ma. So from here, the value of A comes out to be G by 9. So if I substitute the value of A in order to calculate T, so that is equal to 4m into G by 9. So on solving, 4 by 9, value of m is 18 kg into G, that is 10. So on solving this, it comes out to be 80 Newton. So on comparison, the value of K comes out to be 80. So the correct answer for question number 11 is 80. Let's move to question number 12. In question number 12, a block of mass m is equal to 6 kg lies on a horizontal slippery surface. In the upper surface of the block, there is a cavity with the shape of half cylinder with radius r. A small ball of mass m is equal to 3 kg is released at the upper edge of the cavity. Normal reaction on the ball when it reaches to the bottommost point of the cavity after the release is k into 10 Newton. So we have to calculate the value of k. Since the surfaces are smooth in contact, so I can say that the motion of the ball small m is under the action of two forces, that is gravitational force and normal reaction. Since the work done by normal reaction is 0, so I can say that the instant when the ball reaches to this position, so at that moment the velocity of this ball is v1 and the velocity of the block of mass m is let v2. So I can say that since there is no horizontal force acting on the system in x direction, so the momentum of the x direction is conserved. Or I can calculate the relative velocity of the ball with respect to this point. So the relative velocity of the ball with respect to this point is, with respect to the center of the half cylinder, is equal to v1 plus v2. So if I will apply the principle of conservation of mechanical energy, then I can say that mgr is equal to half, if I write in the form of reduced mass of system, then small m into capital M divided by small m plus capital M into v relative square. So from here we get the value of v relative square divided by r. So if I write the free body diagram of the ball at this moment, so at this moment mg is acting in this direction and normal reaction is acting in this direction on the ball by the block capital M, and it is moving in this direction with v relative. So if I write the equation, then I can say that n minus mg is equal to m into v relative square by r. So if I substitute the value of v relative square by r, then we will get the value of n. So the value of n comes out to be small m by capital M into 2m plus 3m into g. So if I substitute the value of small m, that is 3 kg, and capital M, that is 6 kg. So let's check what is comes. So 3 by 6 into, so this comes to be 6 plus 18 into 10. So on solving this, it comes out to be 120 Newton. So on comparison, we can say the value of K is equal to 12. So the correct answer for question number 12 is 12. Let's move to question number 13. In question number 13, a light rod of length 3L is attached to the ceiling by two strings with equal lengths. Two balls with mass m and 2m are fixed to the rod such that the distance between them and the distance from the ends of the rod are equal to L. The tension in the left string just after the right string is being cut is T equal to x by 99 mg. We have to calculate the value of x. So first of all, I calculate the position of the center of mass of the given system with respect to this end. So if I consider this as my origin, then the position of the center of mass can be written as m into L plus 2m into 2L divided by 3m. So from here, it comes out to be 5L by 3. So suppose if this is the position of the center of mass, 5L by 3, this is the position of the center of mass, and this distance is 5L by 3. So we can assume the mass 3m of the system is kept at a distance of 5L by 3 from this origin. So at the moment when this string is cut, so if I draw the free body diagram, 3mg is acting in this direction, t is acting in this direction. So if I write the equation, then 3mg minus t is equal to 3m into acceleration of center of mass. Now we have to calculate what is the acceleration of center of mass. So in order to calculate the acceleration of center of mass, first of all I am writing the equation of torque about this point. So torque about the origin can be written as 3mg into 5L by 3, that is the clockwise torque, is equal to I. So I can be written as ml square plus 2m into 2l ka whole square, that is 8ml square, and multiplied by alpha. So from here the value of alpha comes out to be 5g by 9l. So the acceleration of center of mass can be written as alpha into 5L by 3. So alpha is 5g by 9L into 5L by 3. So the L gets cancelled out. So it comes out to be 25 by 27 into g. So if I substitute the value of acceleration of center of mass, then we can calculate the value of t. So t comes out to be 2 by 9 of mg. So on comparison, it can also be written as 22 by 99 into mg. So the value of x comes out to be 22. So the correct answer for question number 13 is 22. Let's move to question number 14. In question number 14, neglecting the mass of the rod, the time period of a small oscillation of the block of mass m in the arrangement shown in the figure is t is equal to 2 pi by 9 under root zm by k. So we have to calculate the value of z. So this is the equilibrium situation. Suppose from this equilibrium situation the block is descended by a distance x. So in that case the extension in this spring 1, if I consider this is my spring 1, this is my spring 2 and this is my spring 3, then the extension in spring 1 is x. Let I assume that the compression in both the spring 2 and 3 be x1 and x2. I am considering the compression. So if I write the equation of the constraint, suppose this rod is rotated by an angle theta. So if I write the constraint, then I can say that this point is extended by a distance of x minus x1, because when this block is descended by a distance x, this spring also moved down by a distance x, but there is a compression in this spring which is x1. So the net extension will be x minus x1. So I can say that, so that angle theta is equal to x minus x1 divided by L by 2. And this must be equal to the angle theta at this point. So this is equal to, suppose the compression is x2, so x2 by L. So from here we can say that the value of x2 comes out to be 2 times x minus x1. So now, since the mass of this rod is 0, so the net torque acting in this rod must be 0 about this point. So if I see there is a compression in this spring, so due to this the force will act in this direction on this rod and torque will act in this way. So the torque is equal to k into x1, that is the force acting at this point, into L by 2, and this torque is balanced by the compression torque at this point. Since this spring is in compression, so the torque of this spring force will act in this direction. So that must be equal to k into x2, that is the force, into the point of application is at a distance L, so that into L. So from here we can get the value of x2. The value of x2 is x1 by 2. So if I substitute the value of x2 in this, then x1 by 2 is equal to 2 times x minus x1. So if I solve this, x1 is equal to 4x minus 4x1. So the value of x1 comes out to be 4x by 5. So if I write the restoring force on this block, so the restoring force in this direction will be Kx plus K into x1, and x1 we have calculated 4x by 5. So this is the restoring force. So if I divide by mass, this is the restoring acceleration, and that acceleration must be equal to omega square into x. So from here we can calculate the value of omega. That comes out to be 9k by 5m under root, and this is equal to 2 pi by capital T. So from here we can calculate the value of capital T. Capital T comes out to be 2 pi into under root 5m by 9k. So if I see this, the value of T is given. So if I compare with the given value of T, then I have to multiply it by 9 and divide by 9. So this multiplication is within the under root. So it can be written as 2 pi by 9 into under root of 45m by k. So on comparison, the value of z is equal to 45. So the correct answer for question number 14 is 45. Let's move to question number 15.